Hello everyone, welcome back to Algorithm and Data Structures course. In this semester, we will going to talk the following topics: dynamic programming, also called DPM, and graphs. So let's start. What is DP? DP is approach that allows to us solve several kinds of problems. In this class, we will consider these problems and solve them using DP. To solve these problems, we need, using DP, we need to answer for these questions. So the first question: what sort in DP? DP is usually an array that contains numbers, that contains the answers for the tasks that similar and simpler. The second question: base of DP. Base means obvious answers that we need to fill in our DP array. Okay, next is the recalculation formula. This formula allows us calculate new answers based on previous answers that stored in DP. That was stored. Okay, the next question: order of recalculation. Usually order is trivial, but in this class we will consider the problem where order non-trivial. Okay, when we answer for these questions, we will solve our task. And how to prove this solve will be that the solution is correct. It can be proved by mathematical induction. It's obvious. This will be a mathematical induction base, and this will be induction step. These questions will be induction step. So let's begin. So let's move on to the tasks. Okay. The first task about grasshopper. So there is a grasshopper that jump only one or two steps, and it takes the number and sums it up. So the target is maximize the sum of the visited values. Okay, this task can be solved using DP. And the first question: what stored in DP? We store the max sum if the ladder limited by e steps. Okay, the second question: base of DP. Let's suppose that the first ladder will contain null, because when our grasshopper begins to jump, he takes nothing. Okay, third is calculation formula. Suppose that our grasshopper is located on e step. It means it takes the number ae and add it to sum that he took. Okay, he took max sum on e-1 step, or he took max sum on e-2 step. So the contain max sum if the ladder is limited by e steps. So we need to choose. We took this. We took this value or this value. Okay. I remind you that we know all the answers, all the previous answers. dp null, dp null, and so on, and dp e minus 1. The next question, the order. This will be trivial because if the grasshopper located on e step, he need to know only dp e minus 1 and dp e minus 2. Okay, so where is the answer will be? The answer will be in dp n. Okay, this task can be solved by different approach. It can be solved greedy. And what's greedy means? A greedy algorithm is an approach for solving a problem by selecting the best option available at the moment. It means, in particular, it means if the grasshopper, suppose the grasshopper is located on e step, that it take the best option. The best option, consider these two ladders. The best option will be -4. Okay, it will be -4. But notice that it's not bad solution if we took this example, because he take -4, then it take -6, then it take 5, but it can take -6, then -5, wait, then 5, and it will be it will be not best solution. So if we consider 3 steps, we consider more cases. I guaranteed you that the dp method is better than greedy in this task. Is more simpler. I remembered that we forgot about complexity at all. Complexity in memory. Let's calculate it. Complexity will be of this algorithm will be trivial, O(n). It's obvious. And memory of this algorithm will be O(n), but it can be proved. We don't need to store all the values. We need to, in each iteration, we need to know only this value, and this value. So it can be proved. Memory can be proved by O(1). Okay. Let's move on to the next task. The task about turtle. Turtle moves only this direction or this direction. It again takes numbers and sum it up. So the target is maximize the sum of the visited values. again. So the first question. What's stored in dp? In dp we store maximum sum of paths 1, 1 to eg. I noticed that paths can be various. The turtle can move like this or like this, and we will contain the maximum sum, the maximum path. Okay, the second step is the base. What answers will be obvious? Answers on this row will be obvious, and answers on this row will be obvious because the turtle can move only right or down, and can be move up or left. It will be just a sum. The next step is recalculation formula. Suppose that turtle located in this position. Here it takes eg, and it came from here or here. We suppose that we'll know all the answers in this and this area. So we know these answers are the answers for maximum path, and we choose maximum. And we choose the maximum of these two paths. Okay. So, what is the order? The turtle can be moved like this, and I think it's true. Okay, it can be moved like this, and it takes the numbers and sum it up. So the pair can be calculated like here, like this. Okay, because we need to know only this, only e minus 1 g cal or e g minus 1 cal. It's not turtle, it's a way to calculate the pair. So where is the answer? The answer will be dp and m. The turtle will reach the end here, and we will know the answer. What's the complexity of this algorithm? It's obvious. O and m. What is the memory? It also can be improved by OM, because if turtle moves like this, and suppose the turtle is located in the scale, we need to learn this answer and this answer, and it means we need to contain only this and this array. So the memory can be proved by OM. Let's move on to the next task. The pair approach can be different it can be forward style dp. And what is the forward style dp? Consider the follow as a task turtle. Suppose that turtle located here in EG, and in this approach, the turtle want to push information to here and here, and if we consider this cal, the p e plus 1 g, what is the p, what it can be, what it just what it can be store. It can be store maximum. It can be store this value plus the p this value plus the p eg plus this, or maximum was pushed previously. Okay, analogically in this cal, the order can be the same. Let's move on to the next task, and the next task is longest common subsequence. So we given two strings s and t, and we need to I noticed that okay, the length of s and t can be different, and the target is find longest common subsequence of s and t. What is subsequence? Subsequence in this task means not slice. It's concatenation of slices. I mean, if we erase some characters, if we erase some characters, we will get slices. We can concatenate it in the same order. It will be subsequence. Okay, the first answer, the first question: what is the p? The p in this task we will consider 2D array, the p eg. In this task, the p eg, the answer, if we were to solve a task where the length of s will be e and the length of t would be g. The second question: what is the base? Suppose the p null, it means s with null characters and t with null characters equal to null. Suppose it. And third question, calculation formula. Okay. Suppose it's not convenient. Suppose as we is located in position where s contains e characters and t contains g characters. Okay, and we consider a case where whether this symbol was took or not. If it took, we just update it. It means that it's not not included in our list, and it means it means we can take the pair e minus 1 and g, and in the same key and if we not isn't if we took only g, we just analogically took the p e g take the p e g minus 1, and third way, if we added it them characters, if we add characters both, we just put previous previous dp answer and add it, increment it if se if these characters are equal. Okay, what is order? His order is obvious. And what is complexity? It's O len S len T, just O len S multiplied by len T. And what's the memory? Analogically can be improved because order is trivial, and it will be len S. It will be len S. Okay, let's move on to the next task. Longest increasing subsequence. Subsequence means the same in this task, and we consider the following sequence. The target is find the target is find list of longest increasing subsequence of A1, A2, AN. Increasing means if we consider subsequence, elements of this sequence is located in linear order. For example, if we have something like this, login subsequence, in this logis increasing subsequence, in this sequence will be 1, 2, 3, and 4. Okay, what is the first question? What starts in dp? dp e is the length of this in this subsequence. Okay, what's the next question? We can fill dp null by null equal to null. And third question, most interesting question: what's the induction step? What's the step? We have dp e. We have, suppose we know we want to improve our result, and we consider this subsequence a g, so on a I minus 1. What is the gain? What is the cases? We must iterate for all the answers, and if ag, if for this answer dp, if for this answer dp g ag less than ai, then we try to improve. Then we try to improve our maximum, improve our value, and we take this number. We want to take this number. Once again, we take max. We take max for the p1 to e minus 1, and we take max if ai, we take it to the max if ai less than ag. We just iterate through array and look if can we continue our sequence, our least longest increasing subsequence. And if we can't, we just if we don't, if we suppose we in this example we located is in this position, the p3, and this the p not 3, 4, and in this position we don't this set is empty. Okay, in this when we trying to calculate the p4 in this example, so we choose So we choose if it's just if set is empty, we consider that is null and take 1. Okay, I think you understand. So the order we suppose that dp null equal to null, and we fill all the once again we fill dp e equal to 1 in algorithm. It's for if we meet the empty set, we just choose 1, and if hg less than ai, then we just take, then we trying to contain our subsequence here and choose, and trying to contain our subsequence, we choose dpe or dp or 1 plus dpg. If we can't, we take dpe. Okay, what's the complexity? Complexity will be O(n) squared, and it can be improved, but it will be later. And what is the memory? The memory will be O(n), and it can be improved because we need to know in this task, we need to know all the answers, all the dpg, okay? In each iteration, on each iteration. Next, note, this task, if you implement, suppose you implemented this algorithm, you can solve last increasing subsequence problem using LCS. Just take B assorted A without repeating characters. So why is it true? Take a look at in more general way, I think. So explain this more detailedly. Consider this subsequence and consider sorted the sequence without repeating characters. Take a look. Let's take a look. If this sequence is contained, with longest increasing subsequence, some increasing subsequence, it will be contained here, okay? In because it keeps the order, and this task solve the task of longest common subsequence, and longest common subsequence and longest common subsequence that is increasing will be longest increasing subsequence. I'm sorry that I explained a few tasks. Okay, and see you later in the next seminar.